Okay, in this session, we will learn all the main concepts of Docker, including getting your first hands-on experience with it. So if you must use Docker at workplace, or if you need to learn Docker to level up your engineering skills, so this is a good place to learn. So I'll try to cover some main concepts and help you to learn basics of working with Docker today. First, we will start by explaining what Docker is really. Why was it even created? Basically, what problem it solves in engineering, and how it helps in software development and deployment process, so you will understand exactly why Docker is such a big deal today. So Docker is, as you know, is widely used in IT projects. It provides a standardized format for packaging and running applications. It creates an image of the application that includes all necessary software and dependencies, so which can be used in multiple identical containers, which is a consistent and isolated environment, as you can see in this picture. It's like a virtual shipping container for application, providing portable, self-contained ecosystem, right? So Docker is like a virtual machine, but it's lighter and more efficient. So it allows you to package your application into a container. So Docker run the application anywhere, so without having to worry about dependency or capability issues. So initially, managing physical servers was challenging, and virtualization emerged as a solution, if you remember. And however, virtualization is still required individual attention, right, for each virtual machine. Docker provides a more efficient and a streamlined approach by allowing multiple isolated environments within a single host, also known as human body, that runs multiple organs, right? Therefore, Docker can be seen as an evolved human who can run multiple virtualized environments within a single host. So in simple words, Docker is still is a virtualization software that makes developing and deploying application very much easier compared to, for instance, how it was done before Docker was introduced. But also, what I want to actually okay, sorry for interruption. So we were talking about the virtualization software. So in simple words, Docker is a virtualization software that makes developing and deploying application very much easier compared to how it was done before Docker was introduced. So it includes everything, including the dependency and runtime environment configuration, and its running environment are both packaged in a single Docker package, which you can easily share and distribute it. So question is, why is this a big deal? Actually, how are application actually developed and deployed before Docker was introduced? Let's see that what's the benefit of Docker clearly. So before containers, developers would install the necessary services on their operating system, creating potential capability issues and increasing the chance of errors during installation. So each developer in the team would have to install the service on their local environment, which would be different depending on the operating system, right? This process could be time-consuming and error-prone because you have dependencies and third-party services. So what if we need installation 10 times for each service, for instance? So this approach or this process of setting up a new development environment could be pretty tedious, depending on how complex your application is. For example, if you have 10 services that your application is using, then you would have to do installation 10 times, right, for each service. And again, it will differ within the team based on what operating system each developer is using. So dependency version conflicts and miscommunication always happen between development and operation teams, which could cause setup and deployment during the setup and deployment, right? So these issues can arise due to incomplete or unclear instructions, leading to miscommunication overhead. Back and forth communication could happen. So therefore, it's important to have a clear and concise documentation to avoid miscommunication and facilitate the setup process. So containers solve the problem of installing services directly on operating system, right? By packaging services in isolated environment, indeed. So with Docker services like Postgres, for instance, or Redis or SQL or Ubuntu, with a specific version, are easily accessible using a single command that fetches the container package from the internet, and the command remains the same across different operating system and services, which is a big thing. With Docker, so you can easily run multiple services on your development environment. So running a few Docker commands for each process, you can standardize it and making it setting up the local development environment faster and easier. So it allows you to focus on development instead of configuring services and so on and so forth. So Docker also allows running different version of the same application without conflicts, which is difficult to achieve without Docker and containers. So as you can see, there are some commands that you can easily execute, like Docker run Postgres, Docker run Redis, Docker run Nginx SQL, so on and so forth, which is a great achievement. So Docker is a virtualization tool, as we said. that differs from traditional virtual machine. So understanding how Docker works on a technical level requires knowledge of operating systems, kernel, and application layers. So the kernel communicates with hardware components like the CPU and memory, while the application layer runs actually on top of the kernel layer. So Docker does not install services directly on operating system. No. Actually, it runs like containers on top of the kernel layer, acting as a middleman between the application and the underlying hardware. So this is where it interacts between hardware and software components. So both Docker and VMs or virtual machine are virtualization tools, but the main difference lies in what part of operating system they virtualize. So Docker can virtualize the application layer containing only the necessary application using the host kernel, while VMs visualize the entire operating system, including the kernel, right? So therefore, when downloading a VM image, it puts up its own kernel instead of using the hosts. This distinction is important because especially when you want to choose between Docker and virtual machine. So to summarize, Docker packages have a smaller size as they implement only on one layer of the operating system, whereas virtual machine images can be several gigabytes. This means that Docker saves a lot of disk space, and containers can be started much faster than VMs because they reuse host kernels, right? So virtual machine takes several minutes to start up, while Docker container usually just start up in seconds. So if your main priority is resource efficiency and rapid application deployment, Docker can be the best choice. However, if you require complete isolation between the host and guest operating system, or if security is concerned, maybe VM might be a better option. So Docker, again, to summarize more, Docker is a lighter one. It's more nimble. Alternatives to virtual machine streamlining development and deployment process. And Docker can be compared to Lego bricks, for instance. So a single purpose knife or personal assistance, while VMs can be compared to jigsaw puzzles or Swiss Army knife. So Docker is like a personal assistant who knows exactly what you need, while VMs are like a whole team of assistants with many different skills and knowledge areas. So in other words, Docker was designed for portability. You can actually build some solution using Docker container. And no matter where you want to host it. Okay, so very quickly, we take a look on architecture of microservices versus monolithic, although it's not directly about the Docker, but it can be helpful. So monolithic architectures, as you know, refers to a software design approach where an application is built as a single and, say, unified unit with all of its components tightly coupled together. So microservices, on the other hand, break down application into small, independent, deployable services that communicate with each other through APIs, if you know. So in contrast, monolithic applications are usually deployed as a single unit, making them more difficult to scale and update. With Docker, monolithic application can be containerized and deployed actually as separate services, so making it easier to manage and update individual component without affecting the entire application. So in fact, monolithic systems are like a big fat elephant, as you can see in the picture, while microservices are like a group of nimble, agile monkeys. So Docker is like a zookeeper somehow that helps keep all those monkeys organized and well-fed, if it makes sense. So in another metaphor, we can say monoliths are like a giant, heavy boulder, while microservices are like a collection of smaller, more manageable rocks. So Docker is like a wheelbarrow that helps you move the rocks around more easily. Or like we said before, a monolith is like a big, heavy block that made of many parts. Imagine a big toy castle, for instance. So if you want to change something, you have to change the whole thing. That's the problem with monolith architecture. Microservices are like those little toy houses that can stand on their own, right? They don't depend on each other. You can still change each one you want. And again, like we said, Docker is like that magic box that contains all necessary components for software to run, including libraries and runtimes and dependencies and codes. So by using Docker, developers can easily share and deploy software, ensuring consistency. Okay, now we're going to talk about some main objects of Docker. So in Docker ecosystem, or in Docker world, we have three main objects. We have Dockerfile, we have Docker image, and we have Docker container. Dockerfile is a text file that contains instruction on how to build a Docker image. So it's like a recipe that you follow to create your dish, your meal, your food. Docker image is a lightweight, standalone executable package that includes everything needed to run an application. Include code, it includes libraries, system tools. So it's like a package launch box that you have with it, with dish inside and ready to be deployed everywhere. Now, Docker container is a running instance of Docker image. So it's like you enjoying your meal from that launch box while you are at work. So everyone else looks on you with envy, right? You're enjoying it. The container runs in its own isolated environment, making it easy to manage and deploy applications. So Dockerfile is something like this. As we said, it's the instruction on how to build a Docker image. And we can use another metaphor. Dockerizing for software development is like really using pre-built components to build a house. So instead of starting everything from scratch, you can use Docker images to assemble your application quickly and easily. And it's because it saves time and effort and money for you. Dockerizing streamlines the development and deployment process and making it more efficient and faster. What else? What other concept we need to know is that we have, like we said, Dockerfile, Docker image, and Docker containers. So using the command Docker build, we build the Docker image. So images are blueprint for building containers. So we execute this and we get our Docker image. We execute Docker run and we get a new instance of container. So each Docker image can have several actually running Docker container independently. So you have containers which are runnable instance of different images or same images even. Another concept is Docker Hub. So Docker Hub is an online library where user upload pre-built Docker images containing all necessary codes and dependencies. So other can use these images. It's like GitHub, for instance, that people and developer can create and share their new version of containers, and they commit, change, and push them to Docker Hub. So very, very similar to GitHub for development. So it is making it easier to share application and collaborate. Now let's talk about some real world examples. Right now that we are talking, Spotify as one of the most popular music streamlining software is using Docker. So Spotify migrated to microservice architecture using Docker to improve their scalability and resilience. I think the Spotify started migrating to microservice architecture in 2014. It means around 7-8 years ago, and completely migrated in 2016. Capital One also migrated to microservices using Docker in 2017. So now they are able to deploy change faster with less risk of disrupting the entire application. eBay is another example. So eBay company migrated to microservice, again using Docker, and they broke down their monolithic application into smaller modular services. Walmart is another company, adopted microservices using Docker to improve their agility and innovation capabilities. They did that in 2015. They began the process, and by 2016, apparently, they completely migrated to microservice architecture using Docker. IBM, another example, moved to microservice architecture using Docker to modernize the legacy codes and applications. They did such thing in 2014 and actively contributing to the technology as part of its open source initiatives. Okay, so as we said, we have a Docker Hub, which is a platform like what we have in GitHub for development. So when you install Docker Desktop in Windows 10, you have such capabilities that brings a Linux VM to host the Docker inside the Windows as well. So when you create a Docker container, it runs inside that Linux VM in even Windows 10, for instance, which provides a consistent and isolated environment for container to run it. So this allows you to run Linux-based containers on Windows, even if you don't have a Linux machine or Linux installation on your host machine, which is a very good benefit. So I will try to share some real codes and snippets today for you as well with such thing. So if you want to share Windows, so as you can see, this is the Docker desktop, which we can install on Windows 10, for example, which can simulate some capabilities of Linux VM and enables us to make and take advantage of Docker containers and images. So this is something like Docker Hubs. You can find more images on Docker Hub, but here are categories like databases, Postgres, MySQL, MongoDB, MariaDB, or something like even web servers, Nginx, or images like cache, like Redis or Memcache. And we have the links for actually finding more images on Docker Hub, like Alpine, BusyBox. And it's recommended that you use the official Docker official image or verified publishers. So there are some suggested one, or you can search whatever you want, like Ubuntu, Python, Redis, Postgres, Node.js, Apache, Docker. Even you can have Docker in Docker, which is very interesting. And Golang, WordPress, CentOS, etc., etc. Like we said, this is our Docker desktop. It includes container tab, images tab, volumes. Today we would more talk about containers and images. We were talking about the installation of Docker desktop on Windows 10. So we have some basic commands in Docker called Docker build, Docker run, stop, ps, images, pull, push. Docker build is for building an image from a Dockerfile, like we said here. If you remember, we said that based on from the Docker image, you can have several containers, but for getting the Docker image itself, you need to have a Dockerfile. For creating the Dockerfile, you have some steps and commands. Anyway, Docker build builds an application. So Docker build is like building a Lego creation involving a series of steps and pieces coming together. This command acts as a blueprint. So it's like a guideline of assembling the container. So Docker run runs a container. Docker stop stops a running container. Docker ps lists running containers. Images lists all available images. Docker pull and Docker push to pull and push, obviously, to the registry or Docker Hub. We will for sure make an example for each of these. We have ports. Docker container ports are like doors on a house, or it allows traffic to enter and exit. So host ports act like doors in the wall, leading to specific container ports giving control over traffic. Together, they provide a safe and controllable environment for the container to function. So like doors on a house and doors in a wall. So when you want to run a container, we can specify the host port and the container or Docker container port along with the container name. So this is our machine, like our Windows 10 or Linux or Ubuntu, and this is our containers. So we have container port and host port. There are some specific Dockerfile syntax. So we have from keyword, work directory, copy, blah, blah, blah. From specify the actually base image that we want to use as a Docker file as an initial point. So it's like the chef selecting the ingredients for a recipe. So they specify the base image for the container. It's similar to telling the chef where to get their ingredients. So choosing a trusted base image from, like we said, from instruction helps to create a containerized and actually application quickly and efficiently. So just like a chef would choose the best ingredients for their dish, you can choose the best image for your container. So with the from instruction, you can build your container on top of a trusted pre-existing image, if it makes sense. So it is making it easier and faster to create a containerized application. So that's ready to serve. For instance, we say from Python, and we specify which Python version we are targeting, like 3.9 Alpine or from MySQL, or from Node latest, means the last secure version. Copy, on the other hand, copies files from the host to the container. So it's in Docker, it is like hiring a moving truck to move your belongings from your old apartment to your new place. So it allows you to move files from your host machine to the container by specifying the location on both ends. The copy instruction simplifies the process of transferring files, just like hiring a moving truck that makes moving easy. So for copy app.py, which is a Python file, to the roots of that container, or copy requirement text to the roots of the container. So this is the copy, which is obvious. We have also run command. So run command runs a command in the container. So it's like you can consider it like a recipe in a cookbook. So it tells you the steps needed to create a dish, create a food. That run instruction list out of steps needed to build an image. So for example, if you were making a pizza, a recipe might say preheat the oven to 400 degree Fahrenheit, for instance. Roll out the pizza dough, then add tomato sauce and add toppings, bake it for 15 minutes. Each step builds on the previous one, and eventually you will have a finished dish, right? So similarly, in Dockerfile, run command is an instruction that lists out the steps needed to build an image. So each step add to the previous one. So just like following a recipe, the run instruction, it's like an instruction that lets you create a series of steps to build. So your image will be built one step at a time. So for instance, we say from Ubuntu latest, run apt-get update or apt-get install Python 3, or from Alpine, run this command, or from Node, run npm install globally Angular CLI. So what's the difference between run and command, or CMD? We have also CMD. Let me talk about CMD at first. So CMD specifies the command to run when the container starts. So this is the executable part of your container, Docker container. So you specify the argument that will be passed to the executable. For example, if you run a Python script, you will say Python app.py. So eventually it will run at the end of a Docker image. Or you can, in an Angular application, you say at the end, command npm start. Okay, now that we explained the basics concepts of Docker, we have half an hour or more to have some code samples for you. So as we said, we covered the basics of Docker, and we can dive into some real examples. I chose MySQL and Elasticsearch and Angular. So if we have enough time, we can have these three. So for MySQL, we will be using the official MySQL image from Docker Hub. We will show you how to create a new MySQL container and set the environment variables, run SQL commands in the container using the MySQL. So we will provide the code snippets if you like. And throughout this session, it helps you follow along. So let's get started how Docker can make our app development process more efficient. example number one that I chose is running MySQL Docker container. Make a new folder called SQL. And in that specific folder, I will create Dockerfile. As you can see, soon after you completely write Dockerfile, the icon of the IntelliSense would detect that it's a Dockerfile, and the icon would show up. Dockerfile without any prefix or postfix. So it's, as you remember, we said you need to start with from the base image, right? So what is our base image for SQL? For SQL, our base image would be MySQL, and it can be, say, latest. We don't use any semicolon, nothing. This file, which located in root folder called schema.sql, right? We want to actually move or copy that into this specific Linux directory. As we said, this directory is where SQL executable will be running one after another based on the alphabetically, based on the first word. So we say go and fetch the MySQL base image, copy this file to that container, and we set some environmental variable. You see, when you say environment, it says you can set some key value per. Very simple. The first key that we would have is the database. Which database we want to use? I will call it MyDB. Okay, and the other environment variable that we want to say is MySQL actually user. For simplicity, I just say my user. My user. And the other environment I want to set is password. Right? Password for simplicity, again, my password. And what else we need? Expose. So we need to expose our port. In what port we want to export our image? Say 3306. Okay, that's it. And now we open up our terminal. So this is our Docker file. Now we need to, if you remember, we said the Docker file need to be built. So it's a Docker build -t, which is a tag. Each Docker image should have a tag. We can call it MySQL or MySQL image. Okay? MySQL image, and we say dot means build it on the root in the existing directory that I'm executing it. Although we forgot something. What? We forgot to say go into that folder. We should say cd SQL. Why? Because the Docker file exists here. Also, this one should go there. So it makes sense. You say Docker build -t, something like MySQL image, and then dot current directory, existing directory, and press enter. So it go and fetch that image, which is MySQL latest, from where? From Docker Hub. That's it. Is there any error? No error. Okay, so now if it's a Docker images, actually the ones that this is the one, latest. It said 7 days ago. Why? Because 7 days ago, something happened in the Docker Hub and someone committed a new change to that base image, if it makes sense. It's like GitHub. Developers always commit and push their latest change. 7 days ago, this base image has been updated, right? Okay. As we were explaining from MySQL version 8, we copied the SQL schema that we had created here. We inserted the table, we created a table called users and orders, and actually we defined some environmental variables like database name, username, password, and expose the port 3307. So again, we go to that folder or directory called SQL. So cd SQL and dir. Yes, we are in the correct place. So we run, we execute Docker build. We call this time with the tag name MySQL image, and the current directory build. We should build the Docker image from the current directory. It gets the different layers from the Docker Hub. Now we want to run that image. We say Docker run this time, and we can call it container name called MySQL container. We can expose the host port. We can get the host port like even 337, same thing in this time. So 07 of the container port, and the base image that we want to create this running container out of it is MySQL image, which we created here above, right? We just actually run it. It says it's already running, which makes sense because we already named the same thing. This time we call it MySQL container 2. There you go. So the container is now, MySQL container is now running without any error. We open up a new actually PowerShell or terminal. Again, we go to SQL one, dir, and we are in the right one, and the actually the command that we need to go execute in order to go to the shell is docker exec -it, which stands for interactive, and the container we call MySQL container 2, right? And it's MySQL image, and username is MySQL. My user -p is the password, which will be prompt later, and the database name was MyDB, right? Now it says into the password, if you remember, we set the password, my password, this is the Docker 2 though, the Docker SQL is, my password was my password, right? You just say my password. Again, my password. There you go. So we are in the MySQL shell. Here we just say select a star from orders. Orders is empty. Select now, this time select a star from users. Should be empty. There you go. Now we want to insert some sample data into those two tables. For instance, insert into users, these two dummy data. Two rows are now there. Insert right, because we need to make sure two records have been added. Same thing for order. For saving time, I just insert some dummy data to orders, 4 records. So now if I say select star from users, we have these users. Now select a star from orders. These orders have been created. So this is how we run a MySQL Docker container in less than 3-4 minutes. In the next video, I will try to actually show you how can we run a Docker Angular application in the same way. Thank you guys for joining today. Please feel free to introduce our group to your coworkers or your friends, the ones that are interested in expanding their network. Although it's like I said, in online events, the limitation are more, and maybe in person setting, we can have a better demonstration and showcasing the capabilities of Docker system better. Okay, thank you guys. Have a good night.